Sir, you're on mute.
Oh, sorry, I don't know how it became unmuted. Okay, can you hear me now?
Yes.
Okay, and it is getting recorded. Maybe some button got pressed. Okay, yes. So I was saying that date time is a module which has multiple classes. It has date time, time delta, okay, time, okay, and each of those classes have multiple methods or multiple functions in it. So we'll see each one of them. The most common and most use of them is date time only. So it is date time um, uh, file module, and within date time you have date time class also. Okay, and now we are going to see what methods this datetime class has. Okay, so I'm going to say from datetime import datetime. Now I'll have access to all the methods of datetime. So to know the current time, okay, I can say current time equal to datetime dot now. And when you print this, okay, you can actually see the current time. So this will read from your local computer. Okay, so this is P1. No, we are running P2. This must be P2, right? Sorry, P2 and run. So see, okay, this is the current time in my computer. Okay, 23 Jan 1st, 2023. Okay, and so see when you have a big program, right? And you want to see how much time that program takes to run. So I'm going to run a simple for loop for I in range 1000. Okay, inside this again I run a program j in range 1000. So this is going to run 1000 into 1000 times. Okay, 1,000,000 times. Okay, and I'll do nothing. Okay, I'll simply say pass, or I'll simply say a equal to 1. So I'm not printing. I want to see how much time this program takes. So what I can do, I can say current time, date time now. Okay, I can say current time again. I'll measure the current time before start of the program and after the program ends. And then now you can say total time taken by the program is, and you can say, okay, so here instead of current time, I'll say end time, something like that. Because if you're using same variable, we lose the old variable, right? I will say end time, okay, minus current time. Now when you run it, okay, so see, it has taken 0.086840. So fast it has run. If I make it 10,000, then what happens? You see, it has taken points. It did take some time to do it. Let me put one more zero here. Then what happens? Okay, it's going to take time, isn't it? See, it took 8 seconds to give us the output. Right? Now, okay. Now, let's when program is running, okay, it was waiting for it to get completed, isn't it? So now what I'll do, uh, I'm thinking that it should display percentage completion, right? So it means, see, this is going to run how many times? Okay, this is going to run 10,000 into 10,000 times. Okay, now if
Wow.
I divide this by 100, okay, if I divide this by 100, that will be 1 minute, 1%, right? So entire thing. Okay, so how do I display how much percentage it's completed? So let me put here n equal to 10,000, let's say, and I put n here and n here. Okay, so this is going to run 10 in 1000 10,000 to 10,000 times. Now how do I know? How do I calculate the percentage here? Okay, so I will have a variable, okay, I, which I is already being used, right? So let me see counter, which is set to 0, and this I'm going to increase here, counter plus equal to 1. Counter plus equal to 1 means, okay, it is getting increased by 1. So counter becomes 1, 2, so on. Now, okay, so now, okay, so counter is 1. So totally it's going to run n into n, 10,000 to 10,000 times, okay, by 1, or 1 by um, uh, 10,000, 1 by, so I'm going to say if counter divided by n into n, and I'll multiply this into 100. Okay, so counter into 100 divide by n. Okay, now this should be equal to your 1 or 2 or 3 or 4. Okay, then we will say that that much percentage is completed. So what I'll do, I will say this mod n into n. Did you understand what I'm trying to say? So see, this is the total value. Okay, let me do with smaller value. Let's say you have to perform something 10 times, something 100 times. So if you complete one step, it is 1%, correct? If you complete two steps, it is 2%. So how do I calculate that? So what I'm doing, I'm saying you take the counter, multiply this with 100 and divide by 100, and if this is equal to, okay, if this is equal to your some integer value, that means if I'm going to divide this 100 by 100, and if this is perfectly divisible, if it is perfectly divisible, okay, if it is perfectly divisible, okay, so that means this should be equal to 0. Remainder should be equal to 0. So 1 into 100 by 100, it is 100 by 100, it is 0. The remainder is 0. Okay, that means how much percentage got completed? This counter percentage got completed. So if counter into 100, modulo n into n is equal to 0, then we say print, okay, counter percentage task completed, right? So 1 into 100 by 100, if this is equal to 0, then 1%. 2 into 100 divided by 100, it will be 2, right? So that percentage of task is completed. No. So counter, it will not be counter percentage. It is actually counter into 100 divided by n. What am I doing? Counter into 100. So if you divide and remainder is 0, the quotient, that is your task that you got completed. Okay, so let's run it and show you what I'm trying to do. Okay, let's run it now. Okay, okay. So there's something wrong here. So it is actually, if you do, so it is 15, 16, 17 is happening, but it is, okay, counter is counter into 100. Now, counter, okay, I think we have to give bracket here. That's what is the problem. Let me give bracket and let's run and see. Yes, now you see. Now it's coming correct. So it was only dividing by n. That's why we're getting per point. Okay. Now it should be divided by n into n. Now you see, it's saying 26% task completed. Right? 30%. So now you know, see, earlier it was waiting. We were waiting. So we didn't know what was happening. Now you know, okay, 37% task is completed. Okay, now 40% is completed. 42% is completed. Okay. So you know that your program is running. It's not, it didn't get stuck somewhere. It is executing and it's running fine. Yes? Did you understand? Say yes, no.
Yes.
Okay.
Yeah.
So this another use of date time. You can know the exact date time and then, so see, totally it took 55 minutes. No, seconds, sorry. No, see, before it took only 8 minutes, 8 seconds. Now it is 55 seconds. 1 or 2 plus or minus, we can understand that, okay, it is maybe something to do. But from 8 to 55, it's too much. What happened was, earlier we had only this much. Now we added an extra step and we added an extra print. There is some time that is being taken to print, isn't it? It is not zero time, 0 second, right? It is taking some time to print. It could be very, very less, but it is some time. If is also taking time. So that's why, okay, if you want your program to be efficient, you should be writing less number of lines of code, less condition, each print, it does take time. Okay, so shorter the program, faster your program will be. Yes, so when we didn't had all these things, it took only 8 seconds to complete. When we added all these things, it took 8 into what? 8 into maybe, not 8 into 8, but 8 into 7. Okay. So almost 6 to 7 times more slow it became when we added these two statements. Did you understand what I'm trying to say? Okay. So this is how you measure the time taken by your program. Okay. Okay. Now I'm going to move this to another file. We don't want to wait for 55 seconds to run our program, right? Let me put it here. Okay. So that's one application of date time. So again, I'm going to use from date time, import date time, date time. Okay. You can actually read. Okay, let me show again what we had done before. So current time, we had date time dot now, right? And when you do now, it gave us year, month, date, hours, minutes, and seconds. Seconds up to 5, 6 decimal places. Okay. So now I'm going to just take the date out of this. I don't want entire thing. I want only today's date. So I'll say date time dot now. Okay. And dot strft time. Okay. So we want substring. Now you can define what format you want. I want year. I want month. I want date. Okay. So you run it. So you'll give you only, so year hyphen, month hyphen. If you want, you can give comma here. I want comma. So you can say comma. You see, year, comma, 01 hyphen 19. You want only year. You can do year. Okay, I'll say current date. You want year. You simply say print uh, current year. Okay, you can say date time. Okay, dot now. Okay, dot year. Okay, they're variables. Okay, so year will give you year. Similarly, you can have month, day, hour, minute, second. So current month, day, hour, minute, second. So you can say second, you can say minute, you can say hour, you can say month, day. Okay, so you can extract each of these things. So date time will have all the information, date and time as well. You pick and choose what you want to work with.
Yes, got it.
Okay. Okay. Now let's talk about time. Okay, we have another thing called time, right? So I'm going to say import time, simply time. Okay. So it will just give you time here. So you can say print current time. Okay, current time dot same strft format, which format you want. You copy and paste it, you get time. Okay, you want to know. Okay, so there's something called time dot time. Time dot time. So see, it'll give you a number. Okay, in computer analysis. Okay, by default, uh, 1st Jan 1970 is referred as first date. Okay, so reference is always done from 1st Jan 1970. So this the time that you see tells you from 1st Jan 1970 till date, till today, how many seconds have elapsed. Okay, from 1970 till date, how many seconds have elapsed. Okay, it is like GMT 1st Jan 1970 is the reference date. Okay, so you can actually calculate time difference because this tells you so many seconds have elapsed since then. Okay. But what we use mostly along with date time is your time delta. This is used for finding difference between different times. Okay, so let's say print. Okay, you have mm, let's say tomorrow's time you want to know, right? If you want to know tomorrow's time, to know tomorrow's time, okay, you can simply say date time dot now, that is current time. Okay, plus time delta plus time delta days equal to 1. Okay. Date time dot now plus time delta days equal to 1. Days equal to 1 means I'm talking about tomorrow. Plus days equal to 2 means I'm talking about day after. Minus days equal to 1 means I'm talking about yesterday.
Yeah.
From current, go 1 day back. Go 2 days back. Go 1 day front. Go 2 days front. Okay. So that's how you can do days equal to weeks equal to, okay, and it'll take you to that. So of course, when you run this will give you day after, no, plus 1, right? Tomorrow's date. Tomorrow is 20th, isn't it? So you get tomorrow's date. Okay. So you can also find the different time zone. Okay. What is the current time? So what I did is current time in my time zone, right? But what is the current time zone in, let's say, UTC? Or let's say, what time are you in, Pavni? Which time zone? Eastern or
IST.
you're in India?
Oh, sorry. I think
Lost your voice. Sorry.
yeah, I'm in Eastern time zone.
Eastern? Okay. So let's see how to find Eastern time zone. Okay. So you for that we need to import time zone. So from PYTZ, okay, import time zone, right? So this is to get time zone. Now I want to know the current time zone, right? So I'm going to say current time in US Eastern E, twice I've written E, right? Okay, is, now you say date time, okay, date time dot now. So now if I do, it'll take my system time. Now here I'm going to say time zone. Okay, and then you mention the zone. Okay, so if it is US Eastern, you say US slash Eastern. Right? It is 9:06, is it? 9
Yes.
a.m. and 6 minutes. Yeah.
Yeah.
So you can get, okay. And if, of course, if you want only what? The date. So you do strft, right? And then you give the format here.
Format
Format is percentage y, capital Y, okay?
percentage. Yeah.
Hyphen, percentage
And
m, small m, okay? And percentage
small
small
d.
c. Capital M will give you minute, okay?
Okay.
So the date is 19th there as well. Okay, cool. So these are some applications of date time library or module. Okay, it's called module in Python.
Yes.
Now you have random module, right? Random module will give you random numbers. Okay, so random module will give you random numbers. Okay, so if I want to get a random number, you simply say print random, sorry, I did not import, I need to import. So import random. So I'm going to say random dot random. So now when you run it, you get 0.6376. You run it again, you get 0.39. So it's going to give you random number, okay? Different number every time. Okay, 17. Let's say I want to get 3-digit random number. What should I do? I want to get 3-digit random number. If I want to get 3-digit random number, I will simply take this random, right?
+2.
And I'll multiply. No, plus 2 will give you 2 decimal places, right? I want 3 decimal places, right? So I'll say
Uh,
into 1,000.
Okay.
1,000 will give you 3 decimal places, right? It's point. See,
Hmm.
random will always give you between 0 and 1.
Okay.
Random number between 0 and 1. Random number between 0 and that's what you get. Now, if I multiply with 1000, so if it is 0.17, it becomes 171.38 so on. And I don't want the point. So I will convert this into integer. Okay. So when you run it, you see,
We
you
will
get
get,
210,
yeah.
210,
Yes, yes. Got it.
359, 125. So what we did, we use the basic functionality. Okay. So basic functionality random.random. So we use that basic functionality and then we have, converted into the format
Indeed.
that we want.
Huh.
Into the format that we want, right? This is how you can do it. Okay. There's another way to do it. So random has another, okay, function called as random integer values. So if you want random number between say 500 and 9,000. If you want a random number between 500 and 9,000, both inclusive, you say rand int, rand int 500 comma 9,000. So now when you run it, okay, it gives you a number between this range, not less than 500, not more than 9,000. You can define your own range. You see, it gives you values between these two. Okay, so this is
Yeah.
your random integer. Okay, you also have random choice. Okay, random choice will take choice as input and will give you, okay, um, um, a number between that choice. So I'll define as a, let's say, as a string, as a list. Okay. Let me define it. I'm going to say choices equal to 1, 2, 3, 4, 5, 6. Correct? Now I'm going to say print random dot choice. Okay. Choice and choices. If you want only one, you say choice and then you give here choices. So see, it gave 4. It will give you random value or random uh, value from this list. So it gave us 4. Okay, 5, 4, 4. You can play the Ludo game using this. Okay, and you also have shuffle. So let's say we'll take same choices and now I'm going to say, okay, so I'm going to say here one value from the list. Now I'm going to do random shuffling. Okay. So random dot shuffle. Okay. So it will take this. Okay. So Okay, so you don't get like this. Okay, so what we need to do is we need to save it. Okay, first I think here I'm going to say output or something, and here,
So,
yes,
um, if we will run again this choices 1, 2, 3, 4, 5, 6, so we will get different number every time, or we will get same
different number. No, that's
output?
why it's called random, isn't it?
Like same command if we run it again.
Same, different. Every time you run it, it is different.
Okay, all right.
Okay.
Yeah.
Every time you run it, it is different. Okay. So it is, see, now this one, see, list will always get updated. So, okay. So if you if you do choices, okay, not I was doing it
Mm.
wrong. So the choice itself will change. The order of this choice will change.
Okay.
Now, when you run it, see, it is 4, 3, 6, 2, 5, right? Next time it will be
Mhm.
1, 3, 5. So we are
Okay,
changing
okay,
the values within the list also. So every time
okay.
you run, it is different, right? Every time you run, it is different. Now you see here, no, I'm doing random here and random here, but both are different. They're not giving same. It is 0748, right? It is 223. They are not same,
Yeah.
right? Yes. Okay. So these are some of the um, applications of random. Make sense? Totally. Okay. Okay. Now, I wanted to talk about one more topic, okay, which is called as map filter reduce. Okay, so map filter reduce, these are extension of list, okay, or you can say these help us to do programs faster. Okay, no, there's one more thing I want to talk about here, the seed. Okay, now see, when we say a random number, okay, it is really not random. Why it is really not random? Because there's always some logic which is being used. Okay, there's always some logic which is used to generate these random numbers. Okay, so what I mean by that is, if I ask you to think of a number, now when you think of a number, you are randomly thinking of a number, anything. But while thinking, there will be something will go in your mind. Okay, something will go in your mind, like, okay, like, let's say you saw a movie today, and that movie spoke about 99 number in that movie, right? So even though it is random, but you will say 99. Something has to go on in your mind, isn't it? Isn't it? So that's the, so we generally use those kind of things in our analysis when we speak about that. So that's what we call it as. So as I said, again, random is really not random. Okay. So similarly, when we ask Python to print random numbers, it is really not random actually. Okay. There is some logic behind it. Okay. Using which they generate random. Right. So every time they use different logic, so it looks, okay, that it's random for us. but it is really not at all random. Okay. So, okay, but if you want to fix that logic, you want Python or you want random to give you same random value every time. Okay. So we can do by something called as seek. I say random dot seed and I say 100. So 100 is a method number 100, formula number 100. It's like this. Okay. So it's like a formula number 100. So when you run this random number now, okay, you get 145, 454, 33636, 215634. Okay, if you run it again, you get exactly same values. If you run it again, you get exactly same value. Okay, the seed is actually a specific formula that it uses. We don't know. It uses some, and seed can be any positive number. You can give any positive number. You can give 1, 5, 1 lakh, 10 lakhs, anything you can give. So random dot seed is a way to fix the thinking of computer. If you are designing a software, during some application, every time you run a different number, your logic may not work, right? So what we do is we fix the seed. And remember, when you are actually deploying in the main application, then we don't give seed. We want random number to be random really, right? But this is when you're developing, that time you may not want random number to be random. That time you want random number to be fixed so that you can develop, you can see the output. Okay, so this seed function will fix the way you think. Seed function will fix the way you look at random numbers. Okay, so every time this is going to give you same output. Seed will give you same output. Is it clear?
So
Yeah.
what is that 100 in that?
That's what a formula
Uh,
number. You can give any formula, any positive number you can give. No limit to it. You can give 1, 2, 500, 1 lakh. It's a formula. Okay. So we don't know what it is, but every time you give seed 100, you get same output. Even if you run on your laptop also seed with seed 100, you get same output. So in a way, you are fixing the way computer is thinking for a random number. It's like telling you, think of any number and let's say it is 550. So I'm telling you, let's think any number and let's say it is 50, right? So seed is like that. Seed is like, think of a random number, but random number has to be formula number 100. So every time if you apply formula number 100, you get same output, isn't it? Same number. And if you change it, output will change. So random seed 100 will give you same outputs. On your machine also, you'll get same output only. Yes?
okay.
Okay. So let's do one more thing for today. It'll take us another 10-15 minutes and we'll wrap up. This is called as map filter reduce. Map filter reduce are application of list. Let's say you have a very big list, okay, and it has lot of numbers in it. Okay, it's a big list and it has lot of numbers in it. Okay, so let's say here you have say distance. Okay, and this is how you define list using square bracket, right? So I defined lot of numbers here. So on. Now let's say these are your distance in meters. And I want to get distance in feet. Okay, so you have so many numbers. Let's say you have 100, 500 numbers, and each of them are distance in meter, and I want to get distance in feet. So I'm going to talk about map. Map works with list where you want to apply same logic or same calculation to all the numbers. Okay, where you want to apply same calculation to all the numbers. Here, distance in meter, okay, is this. So distance in feet, okay, will be something like 3.1 times, right? So 1100 would become 3300, something like that. So your aim is to apply same formula over each of the values. So one option is you run a for loop. You run a for loop and you multiply each value with 3.1 and you get the answer, right? This map gives us shortcut, tells us how to do it in shortcut. So for this, we have to use something called as lambda function. Lambda function, Lambda, lambda function is called one-line function. So it's a function which is just one line. It will have lambda keyword followed by the variable that you want to give as input. Let's say I want to give variable as x comma y, colon. Then what do you want to do? I want to print, okay, or I want to say multiply x and y, something like this. Okay, so this is a lambda function. Lambda function is one line function. Okay, it will first it will take lambda, it will take the input parameter, colon, and logic. So if you can write your function in one line, you can use lambda. If your logic requires more than one line, then you can't use lambda. Then we can't use lambda. In this case, we are talking about one formula, right? So 1100 becomes 1100 into 3.1. So it is a one-line formula, isn't it? So we can apply lambda here, okay, or map here rather. So you say here we will take input only one value, right? Only one value is needed, x, and the output should be 3.1 into x. Did you understand what I'm doing? So I need to take each member from the list and multiply with 3.1. So I'm going to write a lambda function. Lambda function will take input as x, colon, your output is 3.1 into x. Simple. Okay. So this is the main function, core function. Lambda, the input value is x, and then output is 3.1 into x. Great, fine. Now, who will provide the value to x? Somebody has to provide the value to x, right? 110019004500 to x, isn't it? So
Yeah.
map will do that for us. So you say map of lambda comma distances. So map will take distances, take each value one by one and give it to lambda. The output is done. Output is saved. So this is your distance in feet. But problem is, okay, this has to be, okay, print and see, and then we can talk about why we are talking. Okay, so I'm going to say distance in feet equal to distance feet, right? Okay, so you get a object location. So this is what we have converted into map. Okay, the output we want has to be list. So you convert this object into list. That's it. So list of map of lambda. So first we write lambda to give the formula. Okay. Then you apply map over it, convert into list. Okay. Now if you see 1100 became 3410. 1900 became 5890. Okay. So otherwise, if you don't use map, you'll have to use for loop and you have to do a long program. Now that we know how to find time, okay, we can measure the time that is taken by lambda function and also our for loops. Okay, so how do you do same thing if you have to do in for loop? What will I do? I'm going to create a distance feet to empty and I'm going to run for loop for I in distances. Okay, and I'm going to say
Or J in feet.
yes, correct. So I'm going to say value equal to I into 3.1 and now I'm going to add distance feet dot append val, right? And once you are done, you will print output using loops. Output using loops, and you will say here distance feet, right? Okay. Now what I'll do is, okay, let's do without anything here with small number, and you see both are same, right? But it's taking more time, is it? More 3581920.
It should be distance fit to. We are appending it into the existing list.
Ah, you're right. Yes, correct. So that's why it's getting bigger. Okay, perfect, right? So what I'll do, I will not print it because printing will fill the screen with a lot of values. I'm going to multiply this distance with, let's say, 5,000. So what happens if I multiply this 5,000? This list becomes multiply, 5,000 long. Becomes 5,000 long. Now I'm going to say start equal to import or from date time import date time. Okay, I'm going to say start equal to date time dot now. Okay, and I'm going to say end equal to date time dot now, right? And I'll print here total time taken by map, and this will be your start or rather end minus start, correct? And let me do same thing here as well. Okay, I'm going to say start, and this is going to be total time taken by loop. Okay, let's run it and see. Of course, number of lines is less. Number of lines is less. This has 4-5 lines. This has only 1 line, correct? And time, you see, for 5,000 it took 0.005. It took 0.007. Okay, so instead of 5,000, let's make it 50,000. Now let's see how much time. So see, loop is taking more time. This took 0.8 and this took 0.9. Isn't it? You have more lines of code. This is going to take more time, obviously. Let me add one more 0. 6. It took 0.58 seconds. This took 0.76 seconds. Let me add one more 0. Yes, now it's taking some time. Okay, 5 seconds. 7 seconds. You see that? So as you keep on increasing this value, this is going to be more efficient, right? Map is going to be more efficient. Okay. So yeah, I mean, I'll delete it. We don't want to take it so much time, right? Okay. For very small, you don't realize the difference. But when you have bigger and larger values, obviously, and we have just simple into, there could be something like complex, right? 3, 4 multiplication together, 3, 4 operators together, you might have to put. So that will take that many more time, isn't it? So this is a use of map. You can apply single formula over multiple range of values. Okay. So what I'm thinking, we'll stop here today. It's already 8. Okay. So